Welcome back. We are continuing our discussion on calculus, where we are getting the equations of the tangent and the normal to the curve at a particular point. So we have an example on the board where we are saying, find the equation of the tangent and the normal to the curve y is equal to 1 plus 2x plus x power 3 at 1, 4. So we have to get the equations of the tangent and the normal to this curve at 1, 4. So this is how we go about getting the equation. First, we are going to differentiate. So we say a function is that one. So we differentiate. So we say dy dx is equal to, so when we differentiate this, we are going to get 2 plus 3x squared. 2 plus 3x squared. So now we are told at 1, 4. Getting the gradient as a value, we need to substitute the value of x in the coordinate here, then we put it where we have x in the gradient formula, which will lead us to getting the gradient of the tangent and the gradient of the normal. So we have dy dx is equal to 2 plus 3. We substitute for x, we put a 1, so that our dy dx will be 2 plus 3, which will give us 5. So this 5 that we have is the gradient of the tangent. So we have finally dy dx equal to dy dx equal to 5. So this 5 is the gradient. This is the gradient of the tangent. This 5 as our dy dx is the gradient of the tangent to this curve at 1, 4. So we shall use this gradient together with this coordinate 1, 4 into the formula. We shall substitute them into the formula, this formula that we have on the board. M is equal to y minus y1 over x minus x1 to get its equation. Okay. So, if the gradient of the tangent is 5 as our dy dx, then the gradient of the normal will be negative dx dy. Negative dx dy, which will mean our gradient, we could call it m, of the normal would be negative 1 over 5. Okay, so if our gradient of the tangent is 5, then definitely our gradient of the normal will be negative 1 over 5. So we shall now use the individual gradients of the normal to find the equation of the normal with the coordinate that we are given. And we shall also use the gradient of the normal, which is negative 1 over 5, together with the coordinate 1, 4 to get its equation. Okay, so we have the gradient of the tangent as 5. So let us use this 5 together with this coordinate to find the equation of the tangent. Okay, there we go. So we are using this formula. M is equal to y minus y1 over x minus x1. We know our m is 5. Our m, which is gradient of the tangent, is 5. The coordinate where the gradient is 5 is 1, 4. We know the coordinates are in the form x, y. So we shall say, we substitute into the formula, we shall say m. So for m we put the 5 is equal to y minus, where we have y1 and x1, that's where we put the values of x and y. Alternatively, you could use where you have x and where you have y. That's where you could substitute, or you could substitute along here or along here, along here. It's okay as long as you are uniform in your substitution. You substitute in either of these two columns, whether here or here. I've chosen we shall substitute along here. So we shall say y minus 4, because this is the value of y, so we put it here, put it there. Then the x1 we shall also put it there. Okay, so we say y minus 4 over x minus 1. Okay, so once we have this, then we simply have to cross multiply. So we shall say 1 by y minus 4, we have y minus 4 is equal to 5 by x minus 1, we shall have 5x minus 5. Okay, so this is now this. Okay, so we continue from there. We have y. We need to collect like terms. In this case, we have y is equal to 5x minus 5. The additive inverse of negative 4, because we want to transfer it to the right hand side of the equal sign. So the additive inverse of this one is plus 4. So we add it here, where we have minus 4, it becomes a 0, so that it disappears from here. Here we say plus 4. In layman's language, we just say when a number crosses the equal sign, it changes its sign. Since we have minus 4, this crosses the equal sign, we shall have it as plus 4. So this is what has happened. So we have y is equal to 5x minus 1. So basically, this is the equation of the tangent. This is the equation of the tangent to the curve y is equal to 1 plus 2x plus x power 3. So this is the equation of the tangent to this curve at 1, 4. Now let's finally equation of the normal. We know the gradient of the normal is -1/4. So we substitute that one into the formula together with the coordinate. The coordinate is 1, 4. We know the coordinates are in the form x, y. So we shall substitute in the formula. We shall say the formula m. Now m in our case is -1/5. So where we are told m, we shall have -1/5 is equal to y minus y1, so y1 4/x minus x1, x1 is 1. Then we cross multiply so that we shall have 5 times y minus 4, we shall have 5y minus 20 is equal to -1 times x minus 1, we shall have negative x plus 1. Negative x plus 1. So 5y is equal to negative x plus 1 plus 20. Okay, so we transfer negative 20 to the right hand side, we shall have plus 20. Then here it is going to disappear. So finally we shall have 5y is equal to negative x plus 21. Negative x plus 21. So finally, the equation of the normal is x plus 5y is equal to 21. So this is the equation of the normal to the curve at 1,4. So basically, or generally, this is how we get the equations of the normal and the tangent to the curve at a given point. We differentiate the given function so that we have dy dx. Now dy dx represents the gradient formula for the tangent. So once we get dy dx, that will be the gradient formula for the tangent. Using the gradient formula for the tangent by substituting the given point, the value of x in the gradient formula, we get the gradient of the tangent at that particular point. Then using that one, negative dx dy represents the gradient of the normal. So from the gradient of the tangent, we get the gradient of the normal by swapping the numerator and the denominator, then multiply by -1, then we would have gotten the gradient of the normal. So once we get the gradients, one for the tangent and one for the normal, then we use that particular point. We use that particular point together with these two respective gradients for the tangent and the normal. We get the equation of the tangent and the equation of the normal. So basically, this is how we get the two equations. Now, there are many forms of leaving your final equation. This is just one form. But if you left it in another form, there is no issue, there is no problem. Thank you very much for your attention.